I downloaded this dataset and it was a mess. Missing values, error values and inconsistent data. But with a few SQL queries, I turned this into a clean dataset ready for analysis. In this video, I'll show you exactly how I did it. If you want a handy reference guide for common SQL commands, check out my SQL cheat sheets at the link in the description. This is the dataset we're using. It contains sales data from a fictional cafe on a website called Kaggle. It's intentionally dirty, so we're going to load it into an SQL database, analyze the data and see how we can work with it. I've added the link to this page in the description. Click on the download button at the top of the page. If you don't see the download button, you'll have to create an account and sign in. On the pop-up that appears, click on the download dataset as zip button. Then save the file to your computer. Once the file is downloaded, go to where it's saved and extract the zip file. You should see a CSV file appear. This is the data we will import. Now let's import it into a database. In this video, I'll import the file into a Postgres database using an editor called DataGrip. But you can use whatever SQL database you like and whatever editor you like. The process is generally the same. I've already connected to a Postgres server I have on my computer, and I have created a database called test data. I can import the file in DataGrip by right-clicking on this test data database, then select Import Export, then Import Data from File. This window will appear. I'll select the file and click Open. You'll then see this window which shows a range of options and a preview of the data here. Many other editors follow a similar process. This looks good to me, so I'll click OK. The file will then be imported. This message will appear at the bottom saying that 10,000 rows have been imported. Alright, we have our data loaded. Let's start by understanding the data. Our first query is something simple, just a select count. We just saw the message that said there are 10,000 rows, but I'll do something basic and just verify that there are 10,000 rows. We run this query and see the result here. This is good, there are 10,000 rows. Next, we'll see what's in the table. We can do this with a select star query. We run this and see our results here. We can see all the rows and columns in the table. It shows us a few things. There's a transaction ID which I assume is unique for each row. We have an item which is the thing that was sold. There's a quantity which is the number of the items sold. Price per unit is the price and we have the total spent. Next we have payment method, which shows how the customer paid for the order. We then have the location, which looks to be either takeaway or in-store. Finally, we have the transaction date. I can notice a few things with this data and you might notice them too. First, the column headings are a bit odd. Some of them contain spaces and are surrounded by double quotes. This came from the source file. We should update the column headings so we can query the data easier. Next, there are some strange values in the columns. I see some error values and some unknown values, and null values. So we've had a look at our data. Let's see if there are any duplicate rows. We can do this by selecting all of the columns and then a count function. I'll do this because we might find that there are multiple records in the file for the same transaction. This could have happened during the process that created this file. As we write this query, we can see it's a bit messy because of the spaces in the column names. We need to use double quotes in Postgres to refer to them. We'll update the names pretty soon. Now our query is ready, so let's run it. We can see the results here. We scroll to the right and see the top record and all records have a count of 1. This means that this is the highest count value, which also means there are no duplicate rows. We can order by the count in descending order just to make sure. The next thing we'll do is check each column and see what kind of values are in the column. There are only a few columns, so we'll do this manually for each column. First we have the transaction ID. It's probably unique, but we'll check anyway. We select the transaction ID column and the count and group by a transaction ID. We run this and see the results here. It looks like each row is unique. We can't immediately see if there are any null values, but we can write another query for this. I can write this query that counts the rows where the transaction ID is null. We can run this and see the result, which has a value of 0. So we know that each row has a transaction ID. We can do the same thing for the item column. We can see a range of items here. Most of them look okay. There doesn't seem to be any items with similar names but have spelling mistakes. There are some records with null values here. We also see some records with an unknown value and records with an error. I assumed that there was an error when trying to capture these error rows and some other issue to capture the unknown values. This is interesting. It's also a more realistic data set because we can see there is data that is not perfect. Let's look at the quantity column. It should be a simple number, but we'll check. We see most records have numbers, but there are also some null values, unknown, and errors here. We can repeat this with all of the other columns. I'll paste in these existing queries just to save time. For the price per unit, we can see some numbers, but we also see null values, error, and unknown. For the total spent, we see numbers as well as null, unknown, and error too. We see the same kind of result for payment method, a mix of values, but also some errors and unknown values. For location, we have a couple of different values and the same issues with other rows. Finally, the transaction date column shows a lot of different values, but also some missing and error values. So that's a quick overview of the data. How can we improve our data? We'll start by renaming these columns. This will make it easier to work with data for the rest of the video. To do this, we use the alter table statement to rename the column. This might be a little different in other vendors. We can rename the columns to use a lowercase name and use underscores instead of spaces. Our set of alter table statements looks like this. We can run each of these, and the columns are renamed. To check this, we can use a select star query on the table and see the column names are updated. Our columns are now cleaner and easier to work with. Now let's look at fixing or improving the actual data in the table. Let's start with the item column. We can run that select count query from earlier to see what kind of values we have. We've got a range of items sold. We also have a few potential issues. We have some rows showing null, some with error and some with unknown. First, let's look at the null values. A null value in a database means that the value is not known and it's missing. Personally, I think it's okay to keep the null values here. We don't know what item was sold for these transactions, so we won't change these. The unknown values here also mean the item was not known. I think this represents the same thing as a null value. Therefore, we should update these values to set them to null. We could leave it as unknown, but then when we analyse the data, we have to consider records that are null and the records that are unknown. It's easier to have them set to the same value. So let's set them to null. We can do this with an update statement. We run this and the data is updated. What about those error values? We could leave those error values as is because the error value indicates that something has gone wrong. Or we could update them to null because they also represent a value we don't know. In this case, I'll set them to null as well. We can write a similar update statement. We run this and the data is updated. If we run our earlier query that checked for the count of each value, we can see more null rows, but no more unknown or error rows. We've made a slight improvement to the data. What's next? We can make similar changes to the other columns. We saw earlier that a few other columns had errors and unknown values. We'll update this data for the payment method, location, and the transaction date. We run these statements and the data is updated. I'll come back to the price, quantity, and total spend columns later as we can handle those differently. Another fix we can do with our data is on the data types. Let's see what the data types are for our table. Many SQL editors have an Object Explorer panel on the left, where you can expand your database and see the objects inside it. And many of these areas let you see the data types of the columns in a table. We can do that in Data Grip. We can expand these sections and see the data types for the columns. It shows that all of the data types are text. This has probably happened from the import process, which has set the columns to text by default. You might get a different result if you use a different SQL editor or database vendor. We could leave them as text, but it will mean our queries are harder. It will be better if we change the data types on some columns to something more appropriate. It will make our queries easier to write and can improve performance. So we'll change the quantity, price, and total spent to number columns, and we'll change the transaction date to a date column. Another way we can check the data types is by looking at the data dictionary. This is a set of internal tables and views that contain information about the database. The queries are different in each database vendor, but we essentially want to query a table that has details about all of the columns. We can run this and see the results here. We can see that all columns are a text data type. We'll start by changing the data type of the transaction date column. There are two ways to do this. One way is to update the data type directly, changing this column from text to date. Another way is to do it in stages. First, we add a new column with the right data type, then we update the values in the new column, then we remove the old column. It's a few more steps to do it in stages, but generally I think it's better. You can compare the data after you update it to ensure you don't break anything. Let's try that. First, we add a new column. Our new column is called Transaction Date New. It's only temporary, so it doesn't need to have the best name. Then I'll select the ID and the existing transaction date just to see what the data looks like. It looks like the dates are in the format of year, month, day. To convert this to a date, we can use the toDate function in Postgres. Other vendors will have similar functions you can use. I'll select the toDate function so I can see what the data looks like before we update it. We can see the results here, which look the same as the text value, but they are a date data type. It looks good, so let's update the table with this. We'll write an update statement that sets the new transaction date to the existing transaction date, but formatted as a date. We run this and it is successful. DataGrip gives me a warning because I don't have a where clause, but this is what I want to do, so I'll click execute. Now let's see our data. We can see all of the columns, including the new column we added, which is now populated. So far so good. Now we can remove the old column by dropping it in an alter table statement. We run this and it is removed. Finally, we rename the new transaction date column to just transaction date. We run this and it is successful. Our transaction date has been updated and it's now in a date data type, which makes it much easier to work with. We have a few number columns here that need investigating: quantity, price, and total spent. If we look at this data, we can see that the total spent seems to be equal to the quantity multiplied by the price. We can use this logic to update each of these values where the other two values exist. For example, if we have a record with a quantity and a price per unit, but no total spent, we can update total spent as quantity by price. Let's do that. First, we'll find records that meet that criteria. We need to look for records where the quantity is not null and not error or unknown, and records where the price has the same criteria. And finally, records where the total spent is missing, when it is null or an error or unknown. We run this query and see the results here. The results look good. Quantity and price are okay, but not total spent. Let's update the total spent to be quantity by price. We'll write an update query that uses the same where clause. We run this, but we get an error. It says the operator does not exist. Text star text. This happens because we're trying to multiply a text value by a text value. We can update our query to convert those into numbers by using the cast function. We run this and it works. Let's do the same thing for the other columns. First, the price per unit. We'll find rows where the price has a problem with quantity and total spent is okay. Now let's update the price per unit to be the total spent divided by the quantity. We'll have to use the cast function here as well to convert the values to numbers. We run this and it is successful. Finally, we update the quantity column to set it to the total spent divided by the price. We'll find the impacted rows first using a similar select query. We see the impacted rows here. Now let's update the rows. We run this and the data is updated. Let's find out if there are any rows that have data issues in these columns after our update. We can run the same queries as earlier. There are some error and unknown values still in this column, which is probably because they didn't meet our earlier criteria. Let's update these to null values so they are consistent with our earlier approach and so we can update the data types. These records are now updated. Let's update the data types to convert them from text to number. We'll try to update the existing columns rather than create a new column. We write this alter table statement and then run it. I get an error here which says the column cannot be cast to an integer. This happens in Postgres because the conversion is not done automatically. This is an easy fix though. We can add the using keyword and this text here, which performs the conversion. We run this and we get a different error. It says invalid input syntax. It looks like there is an existing value that has a lot of decimal places that can't be converted to an integer. Let's look at our data. It looks like there are a few rows that have a number with many decimal places. We can update the data to round it to a whole number, and then the data type conversion should work. Let's try this. We could use some conversion functions to make it work in a single query, but for this example I'll write separate queries. We run this and it works. We can repeat this for the remaining values that have decimal places. We run this and the data is updated. Let's see the data in the table now. We can see the data is now just numbers. Let's try to update the data type using the alter table command from earlier. We run this and it now works. The data type is now an integer. Let's do this for the other columns. First we'll update the unknown and error values. Then we'll use an alter table statement. We're converting this to a decimal value, not integer, so the change should work. We run this and it has worked. Let's check the data again. We can see there are a range of numbers, some with a decimal place and some without. The data looks good. Now let's do the same thing for the total spent column. First we update the unknown and error values. Then we have a similar alter table statement to change this to a decimal. We run this and it works. We can check the data in the table now. We can see the data looks pretty good here too. Let's look at the full table again. We can see the data is much cleaner. Error and unknown values have been set to null. Some of the numbers have been calculated based on other values and data types have been updated. What else could we do here? Maybe we could fill in the transaction dates using calculations based on the previous and following transaction. Maybe we could fill in average values for missing numbers like price or quantity. Or maybe we can find the missing price numbers from other records that sold the same item. There are more things we can do, but this is a good start to help us with data analysis work. Remember, check out the link in the description for my SQL cheat sheets. Analysing existing data is sometimes messy like this. You'll want to watch this video next, where I import data about car sales and then perform some analysis on it. Thanks for watching.